Hello guys, welcome to this class. And in the last class we talked about classes of levers. And in that class we talked about class 1, class 2 and class 3 levers. First of all, we introduced the type of machines, and the first one was lever. And under lever we know that we have what? Class 1 lever, right? Class 1 lever, class 2 lever, and what? Class 3 levers. And we said that in class 1 levers, what happens? The class 1 lever has what? The fulcrum F in between the load and what? And the effort. And we said that class 2 levers have what? The load in between the effort and the what? The fulcrum. And class 3 levers have what? Class 3 levers have the effort in between the fulcrum and the load. So this was what we did in our last class, right? Now in this class we are going to continue from type of machine. We have talked about lever. We are going to be talking about a pulley. We are going to talk about what? Pulley type of machine. So how does a pulley look like? A pulley consists of a system of rope and wheel. It consists of a system of rope and wheel in which the wheel revolves. The wheel will revolve in a frame. So let me draw it. So the wheel is revolving around a fixed point, something like this. So for example, there's a rope here connected to something like this. So maybe this is the load, right? And this is your hand trying to draw the rope. Now there is something that you need to know, that the more you draw this rope downwards, what will happen is that this load will begin to go up, right? So if this one is coming down, this one is what? Going up. And what happens is that the effort it will take you to lift this load with your hand will be more greater than the effort it will require for you to draw this rope and lift the same load. So what happens is that this pulley system, are you getting it? The pulley system has helped you make work easier. So how do we calculate the velocity ratio of a pulley? Velocity ratio of a pulley. I told you that in machine that we don't have issue in type of machine. What we just need is the velocity ratio, because each machine has their own velocity ratio. The velocity ratio of a pulley is given by V arrow is equal to number, equals to number of pulley block. Number of pulley blocks. So for example, let's do a quick review. Let me quickly sketch a machine, something like this. Now, what is the velocity ratio? What is the velocity ratio of this machine? What is the velocity ratio of this machine? Pause this video and answer. I know you didn't pause the video, but if you get this answer, you were right. The velocity ratio is 3. Why is it 3? Because the number of pulley blocks in the system is what? 3. That is 1, 2, 3. So when we are talking about pulley, we just need to count the number of pulley block in the system, and the number of pulley block in the system will give us what? The velocity ratio. Now let's talk about our next subtopic, which is what? Inclined plane. The inclined plane. Now, what is an inclined plane? What is an inclined plane in terms of machine? When we are talking about an inclined plane in terms of machine, we are talking about a slant height. Are you getting it? A slant height in which a load, this is the load, you can call it load, is being what? Rolled through. A load is being rolled through. This is the force F, or the effort. That was a mistake. Sorry, let me clean it. Alright, so let's continue. So in which what? A load L is being rolled what? Through. And I said that this point is what? The effort. Now let's consider how the inclined plane look like. Now, before we continue, you should understand that it is easier to roll this road through this point than to lift it from the ground to this point, right? Because when you roll it through this point, if it is a smooth surface, you discover that the work will be easy. So that is why we consider it as a machine. Now let us know the velocity ratio of an inclined plane. Velocity ratio of what? Inclined plane. Okay, now the velocity ratio of an inclined plane, let us draw a diagram of how an inclined plane look like. This is the slant height, this is the horizontal axis, and this is the vertical axis, right? Now you should know that at this point there is an angle. There is an angle to the horizontal. Now remember that velocity ratio VR is what? Distance moved by effort, distance moved by effort, distance moved by effort, all over distance moved by what? Load. This is a short form, distance moved by effort over distance moved by what? Load. Now, what is the distance moved by effort here? Remember that in this triangle, this place is the opposite side of the triangle. This side is the hypotenuse side because it's the longest side, and you know this is the opposite because it's what? Directly opposite to the angle, right? And the remaining part become what? The adjacent, right? Now when I place my load here, when I'm pushing the load, remember that my effort will what? Go through the hypotenuse. True or false? My effort will be along the hypotenuse. So we can now replace this VR by saying VR is equal to, now the distance moved by the effort here is what? This side, right? That is what? The hypotenuse, also known as slant height, because slant height, the slant height, all over. Now, what is the distance moved by the load? Remember that even though we are pushing the load is moving from the ground to a point, right? Our aim is to go to this point. So imagine me pushing the load through this point, or carrying the load from the ground to this point, we still achieve the same aim, and that aim is to lift it up a height. So my distance moved by the effort is along the hypotenuse. Now the distance moved by the load is the height from the ground. Are we getting it? The distance moved by the load is what? The height from the ground. If it's here like this, it's here like this. So VRO will be what? Distance moved by effort over distance moved by load, which is now distance moved by load is the opposite, which is also known as what? Vertical height. So we now prove it that VRO is equal to slant height. Is the slant height, right? And we know how we got slant height, which was the hypotenuse, right? HYP, the hypotenuse part over the vertical height. So, and this vertical height is what? The opposite. We derive it in the last page. So velocity ratio for an inclined plane is number 1, slant height over vertical height. Write this down, it's very important. Slant height over vertical height. There is another formula I want you to understand here. This is formula 1. There's another formula we are going to be understanding from this side. Formula 2 is that under trigonometry there is something called SOHCAHTOA. SOHCAHTOA, and this is how it works. SOHCAHTOA, this is SOHCAHTOA. Now, first of all, for us to use this SOHCAHTOA, we have to look for the relationship between hypotenuse and opposite, and that is what? Hypotenuse and opposite, which is what? Sine, because sine carries OH. So S for sine, it therefore means that we are going to say sine theta, are you getting it? Is equal to what? It's equal to what? Opposite, which is what? The vertical height. So we cannot say that sine theta is equal to opposite, right? And opposite is what? Opposite is vertical height all over hypotenuse, which is slant height. Now, sine theta is what? Vertical height over slant height. But we remember that our first derivation, we know that velocity ratio is what? Slant height over vertical height. Now in this case now, sine theta is vertical height over slant height. What does it mean? It means that if I turn this formula upside down, I will have my normal velocity ratio. True or false? Because velocity ratio is the inverse of this formula. So if I turn this formula upside down, I will have my velocity ratio. That implies that sine theta, are you getting it? Is equal to what? 1 over V arrow. True or false? And if we make V arrow subject of formula, that is, we cross multiply, or if we do anything to just make V arrow, here the subject of formula, V arrow will be equal to 1 over sine theta. Are you getting it? So the two formulas here that we just need to note for an inclined plane is that number 1, velocity ratio V arrow is equal to slant height all over vertical height. And number 2, velocity ratio is equal to 1 over sine theta. This is for what? This is for inclined plane. Note this very down. And we know that the slant height is along this point and the vertical height is along this point. Why this angle here is the theta. Now the next part we'll look onto in this course, the next type of machine we are going to be looking onto is called the screw or wrench. The screw and the wrench. Now, in considering the screw and wrench, what do we need to know? First of all, let us sketch how a wrench look like. If we sketch a wrench, and we have a screw or a bolt here that we need an effort, maybe your hand, to turn through. We need to know something that is very important. First of all, we know how the screw look like. This is the screw, right? This is how a screw will look like. And my drawing may not be perfect, but keep on doing it small. This little knot. Now you know that this knot, when I turn it, it will revolve, right? It will make a revolution, it will roll. And one revolution here, the distance of one revolution, for example, when this knot is rotating, when it rotates, is one pitch. Is called pitch. That is the distance here is called pitch. Why this point? So the distance the knot will roll is called pitch. Now remember that the distance from this knot, are getting it? The distance the boat will rotate is called what? One pitch. Now know that the distance from this hand to the spinal is arrow. Why is it arrow? Because it's turning a radius. You turn it through a circular path, right? For example, you turn it through a circular path. It is rotating. You are turning it through a circular path. So what happens is that velocity ratio for this now, V arrow is velocity ratio. By getting into V arrow will be equal to distance moved by effort. Now the distance moved by effort, to know the total distance moved by effort, is the circumference of the cycle this hand is moving, right? We are moving like this. It is forming a circular path. The knot is forming what? A circular path. It is circumference of the cycle, and the circumference of the cycle is what? 2 pi arrow, right? It is circumference of the cycle moved by this hand during rotation. So this hand, for it to tie the knot, it will move in a circular path. So the circumference of that cycle, according to basic mathematics, circumference of the cycle is what? 2 pi arrow, where arrow is the radius of the cycle. Now in this case, now we already have our arrow, so we just need to add what? 2 pi, true or false? So that's what? 2 that will be 2 pi arrow, right? That is the distance moved by the effort, your effort. What was the distance moved by the load? Remember that this boat is what we are turning, and this boat will move one pitch. One pitch is called P, is It's also called, it measures the distance, 1 pitch. So that will be what? Distance moved by load is 1 pitch. That is what? P. So we can say that the velocity ratio for this screw arrange is given by what? 2 pi r over p. 2 pi r over pitch. Just note it. If you don't understand the explanation well, you can comment below so I can explain it better in another video. Don't worry, with time we'll start doing animation, so explaining this with animation will be more better, or putting my screen on the camera all at the time. But for now, let's stick to the formula, which is 2 pi r. R, are we getting it? R is the radius of the wrench, is the distance of the wrench, is the length of the wrench. While P is the pitch of the boat. The pitch of the boat. So the pitch is always given, and the length of the wrench is always given. So when I give you the length of the wrench, you don't know that is what? R. Now, the next class of machine we'll talk about wheel and axle. Wheel and axle. Now, what do we mean by wheel and axle? So, wheel and axle, are we there? Wheel and axle this wheel and axle consists of an axle. Are we getting it? Because they are together, we can't separate them. It consists of an axle that turns a wheel. Consists of an axle that turns what? A wheel. So the effort is applied. The effort is applied to one point. They are together. Are you getting it? Okay, now when, for example, let's imagine that this is a system used in drawing water from the well. So something like this. There's a rope here, and there is a bucket here. Like you see the thumbnail, there's a bucket here. Right? So what happens is that when I turn this wheel, just note one is turning the other. So for example, this is the axle. When I turn this axle, this wheel will be rotating, and when I turn this wheel, the axle will be rotating. So depending on the one I turn. So in this case now, let me turn the axle, because in fetching water, most times we turn the wheel, so it will rotate the axle, right? There are some cases where the axle is rotated, but all are together. So we'll derive it now. So when I turn this part now, it will rotate, right? And this one too, this small axle will rotate too. Now let us consider the rotation. And when the rotation is being done, the work is being done. Now note, when it is rotating, there is a distance move, and that distance is a circular distance. Now let's consider the radius of this wheel, which is what? Big R, and the radius of this axle, which is small r. Now velocity ratio VR is equal to distance moved by load. No, it's equal to distance moved by effort over distance moved by the load. Now, the distance moved by the effort is the distance moved by this axle. It is the distance moved by this wheel, right? And the distance moved by this wheel is the circumference, which is what? 2 pi arrow. 2 pi big arrow. Now, the distance moved by the load is this axle, which is what? 2 pi small arrow, which is the radius of this axle, because this one too will rotate and rotate along the small arrow. Now, what happens here is that 2 pi cancel 2 pi, and all we have is to be V arrow. Are we getting it? V arrow is equal to, we now have what? Big arrow over small arrow. So we now say that for wheel and axle, the velocity ratio is given by what? Big arrow over small arrow. Make sure you write this down. It's very important. Big arrow, where big arrow is the radius of the wheel, over small arrow, where small arrow is the radius of the axle. So it can be given to you in your exam. Now, the next part we talk about is gas. The gas system, or gas, anyone you call it, gas or gas. This system consists of a mechanized machine where we have teeth. The first one has teeth, but both of them has teeth, right? Both of them has teeth. Now, in this teeth gas, one is rotating and the other one is rotating by the rotation of the first one. So the first one, where the energy is coming from, is called the driver gas. It's called the driver gas, and the second one is called the driven gas. It's called the driven gas. Why? Because when this driver gas is rotating, since this one is connected to it, this one too will also what? Rotate. So this is the driver and this is driven. Now the number of teeth here now, is at those points. These are the number of teeth: 2, 3, 4. If we continue to count, we begin to get it clearly. These are the number of teeth for the driver gas, and these are the number of teeth for what? The driven gas. So what happens is that velocity ratio is distance moved by effort over distance moved by load. Now for this, velocity ratio for gas is given by number of driver teeth. Are you getting it? Number of driver teeth over number of driven teeth. What does it mean? In this case now, since this is the driver teeth, it means that the total number of teeth here, if we count those teeth, the total number 1, 2, 3, the total number of teeth here, all over the total number of teeth here. So we say that velocity ratio, are we getting it? For gas, V arrow is equal to what? Number of driver teeth. They can give you the number as 5, anyone, but it will be in number. Driver teeth all over number of driven teeth. Wow. So since we are done now in explaining all types of machines and their velocity ratios, let's now talk about a complex machine. In less than 5 seconds will be through. A complex machine is a combination of many types of simple machines. Very simple. That is the definition. A complex machine consists of the coming together of different simpler machines. So we can make a complex machine by adding different simple machine. We can add a pulley, and a gear. After a gear system, we add inclined plane. Just adding different type of machines, different type of simple machines gives you a complex machine. So thank you very much for following this class. In the next class, we are going to be solving problems, exam problems that are related to this course, so that we'll be able to know how those things work very well. Make sure you like and subscribe, and also share to your friends. God bless you.